Hello and welcome to section 6, and this is a section about square root functions. And so what we want to do is we want to find the inverse of a quadratic function and find the domain of a square root function. So what we have, let's go ahead and find let's look at a quadratic, okay? And let's just write out about how, the quadratic that we see here in orange is y equals x squared. Okay, if we wanted to find its inverse, okay, then what we would get is we would replace x and y. So I'd get x is equal to y squared, and I would take the square root of both sides. So that ended up getting me y is equal to plus or minus the square root of x, okay? And so what happens here is that you end up getting this. You end up getting that, for this portion here, okay, this is the positive square root of x, and this portion here is the negative square root of x, okay? And so what we did is we found the inverse, and the issue is that when you see the graph here, okay, the inverse of a quadratic, this is not a function. Okay, when you have just y equals plus or minus the square root of x, this is not a function, okay? However, if you just think of y equals the square root of x or y equals negative square root of x, and you think of these things separately, then these separately are functions. So separately, these are functions. Okay, and that's it. All right, let's look at the next page. Okay, on the next part, we want to graph the inverse of a quadratic function. So if I have this function here, g of x is equal to 2x squared minus 8, the inverse of that function for when x is greater than 0 is this function here, f of x, okay, square root of 1/2 x plus 4. And then for x is less than 0, the inverse of the function for d of x is the negative square root of x, square root of 1/2 x plus 4. So what we want to do is find some of these values, q, r, s, and t, that, for these x values. So what I want to do is I want to plug these values in. And so in order to find q, that means I need to find d of x. All right, so I'm going to do d of negative 8, okay, which is going to give me negative square root of 1/2 times negative 8 plus 4, okay? And so then here, we're going to get, what is that, negative square root of 1/2 times negative 8. That's going to give me negative 4. So I've got negative 4 plus 4, and that's going to give me the square root of 0, which is just going to give me 0. So q is equal to 0. All right, if I plug in 0 into f to find r, okay, that's going to give me f of 0, which is going to give me, and f is just the positive square root. So we're going to get the square root of 1/2 times 0 plus 4. And so that's going to give me 1/2 times 0 is 0, so we're going to get the square root of 4, which is just going to give me 2. So r is equal to 2. Okay, if I plug in 10 in for f to get s, okay, f of 10 is going to give me the square root of 1/2 times 10 plus 4. Half of 10 is 5, so I get the square root of 5 plus 4, which gives me the square root of 9, which is equal to 3. So s is equal to 3. Okay, and then to find t, I'm going to find d of 10. Okay, and that's going to give me the same thing, except for I have the negative square root of 1/2 times 10 plus 4. And so that's going to give me negative square root of 5 plus 4, so I get negative square root of 9, which is going to give me negative 3. So this is negative 3. Okay, and you could probably find those from the graph, you know, kind of get the idea at least from what those are, but, you know, let's just go ahead and, you know, do them, plugging them in. So let's go ahead and find the inverse of this function. So what I want to do is I want to find the inverse of this function here. So the first things first, I need to replace x with y. So I get x is equal to 2y squared minus 4. And I'm going to solve for y, okay? So I'm going to go ahead and add 4 to both sides, okay? So I end up getting x plus 4 is equal to 2y squared. Okay, I'm going to divide by 2 by everything. So I get 1/2 x plus 2 is equal to y squared. Okay, and I'm going to rewrite that so the y squared is on the left. So I get y squared is equal to 1/2 x plus 2. Okay, and then if I take the square root of both sides, okay, then I get y is equal to plus or minus the square root of 1/2 x plus 2. Okay, and that's my inverse, okay? And we would have two different functions there, okay? We'd have y is equal to the square root of 1/2 x plus 2, and we would get y is equal to the negative square root of 1/2 x plus 2, okay? So you have both, all right? Let's go ahead and move on down to the next one. And what we want to do is we want to complete the square to find the inverse. So find the inverse function of the given function. So what I'd want to do here is I'd want to first replace x and y with, or x with y, okay? So I'm going to rewrite this first as y equals x squared plus 6x, okay? And then I'm also going to write, you know, I'm going to replace this and say x is equal to y squared plus 6y. Okay, and it's kind of hard to solve this for y. So what I have to do is I have to complete the square. Okay, so what I'm going to do is this. I'm going to get this to a point. So I'm going to turn this into a perfect square. And so what I'm going to do is I'm going to take my middle term 6, okay, and divide it by 2 and then square it. So that's going to give me 3 squared, so I'm going to get 9. So I'm going to add a 9 to both sides, okay? And so I'm going to rewrite this as x plus 9 is equal to y squared plus 6y plus 9. Okay, and what I can do now is I can actually take this and I can complete the square here. All right, and so what I'm going to do is rewrite this, and I notice that this is a perfect square. This can be factored into y plus 3 times y plus 3, and that's equal to x plus 9. Okay, and I can rewrite that as x plus 9 is equal to the quantity y plus 3 squared. Okay, now what I can do is I can take the square root of both sides. So if I take the square root of both sides, okay, then I'm going to get that plus or minus the square root of x plus 9 is equal to y plus 3. Okay, and so what I can do from here is I can subtract a 3 from both sides. So I end up getting that y is equal to negative 3 plus or minus the square root of x plus 9, all right? And so you can, you know, look at this a number of ways, and you can say, all right, well, this is really just y equals negative 3 plus the square root of x plus 9, and y equals negative 3 minus the square root of x plus 9. And that's it, okay? And that's what we're looking for. All right, so now, and let's go ahead, let's skip this last one. This last one is the same thing as this top one. I just kind of want to move on from here. Because the big thing that I want to talk about is the domain and range of a square root function. So when I talk about the square root function here, okay, what I notice just looking at the graph is that my domain, okay, goes from values that are x that are greater than or equal to 0, okay? And my range does the same thing, that the y values are greater than or equal to 0. Okay, and the reason is because I can only plug in positive numbers here. Okay, and we kind of learned that earlier in the section that, if you were to take, say, y equals the square root of negative 1, if you plug in a negative number in here, okay, you get an imaginary number. Okay, you don't get a real number out of this. Okay, so you can't take the square root of a negative number, and I'm going to write that up here. Okay, in big bold letters, you can't take the square root of a negative number. Okay, and the reality of it is that you have this this graph here, and when you plug that in, okay, you're not going to get a negative number. Okay, when you plug in a number into a positive square root, it's going to give you a positive number out of that. All right, so you have this issue of these restrictions on a square root function. Okay, and bottom line is that whatever, and so I'm going to write this as well. Okay, so then as a side, whatever is under the square root must be negative. Or I'm sorry, must be positive. Okay, so when you extend that idea out and you say, okay, well, let's consider this function right here, which is, what's f of t, square root of 3t minus 9, what is the domain of the function? What I'd want to do is I'd want to take the value that's underneath the square root, and it has to be either greater than or equal to 0, okay? And so then if I add 9 to both sides, okay, I get 3t is greater than or equal to positive 9. If I divide by 3 and divide by 3, I get that t is greater than or equal to positive 3, okay? And that's my domain, all right? That's my domain. So let's just quickly graph this real quick and just verify that that is, in fact, our domain. Okay, so once I graph this function and I just put an x in there, I know that it's t, but what we notice is that it starts at 3 and it goes to the positive side, okay? So the domain of, having the value be less than or equal to 3, or greater than or equal to 3, is true and it works. So I hope you guys enjoyed this video. I know I went kind of fast and it might be kind of confusing, but we'll talk about it and we'll go from there. Thanks. Bye.